Greetings, my name is Josh Stroshine and I'm going to be talking to you tonight about browser plugins. This content I derived from Chapter 8 out of our Tangled Web textbook. So just to give you a quick overview of what we're going to be talking about, excuse me, we're going to be taking a look at browser plugins, what they are, why we use them, where we typically encounter them, some security vulnerabilities that I'm going to try to highlight as we come across those. One thing I want to point out though is that if you've looked in the book, this is a fairly short chapter. It's only about 11 pages or so, so it doesn't go into any great detail. So my hope for this presentation is just to give you a high-level understanding of how the plugins generally work with the browser, what you can expect, what's available, and then just some real high-level security concerns, or what makes these plugins inherently insecure in the web world. So to begin with, we're going to look at what the browser plugins really do. They're designed to display different file formats in the browser. So a pretty common example of that is the PDF viewer. You can see that in D2L. We can go into the content area of one of our classes and view a PDF document that has been uploaded there just right in the browser. YouTube's another great example, being able to stream Flash through the Flash player, stream video content, audio content directly to our browsers. What the browser does here is that when it provides just a rectangular drawing space and then pretty much backs away and allows that plugin to do what it needs to do. Now, one thing I want to point out is that browser plugins are different than browser extensions. Browser extensions typically rely on JavaScript to tweak the browser content, and I'm going to show you a couple examples of those a little bit later to hopefully make that very clear. With browser plugins, they are the cause of many client-side vulnerabilities. Now, the author argues that there are a couple of reasons why. One is that they haven't endured the same scrutiny as the web, just based off of my assessment is that there's not as many people using them, or at least they weren't historically. The other is that they're just not developed with malicious input in mind. And I know from personal experience that until I got more into the offensive or web application hacking mindset, I just never thought that way. I never thought about how I could try to break an application and send it malicious input. So the next step is, now that we kind of understand what a plugin is, how do you invoke a plugin? The two most common ways are to use the embed or the object tag. Here you can see on my second and third bullets, we have the embed tag with a source property which will point to then that resource. Same thing with the object tag, except that you're going to use the data property. And I'll show you an example here on the next slide of that, using the object tag. Now, to kind of touch back on that rectangular area that the browser hands off, you can control the way that the dimensions of that area are defined through CSS or through some legacy HTML. Again, I have an example of that in the next slide. So what typically happens, well, to back up just a second here, also with those tags, they should include a type parameter. What this type parameter will do is it'll define the MIME type of the content being requested. So what happens is, as the browser's processing the DOM, it encounters one of these object or embed tags, it requests a resource, the resource is returned, and then based on that MIME type, it's going to look up what's been registered active plugins in that browser and then hand that off or route that to the appropriate plugin handler. If no match is found, a prompt should be displayed telling the user that they need to download the appropriate player or plugin. Now, in my process of getting my video here set up, I needed to get the plugin on Screencast-O-Matic. So here you can see just a real simple example of where my browser determined that I was missing a plugin, prompted me for it, and then I was able to install that plugin, the JRE, the Java Runtime Environment in this example. So, as promised, here's an example of an object tag. This is actually code I wrote or use on one of the websites I developed. The first line here, again, using that object tag. Then I have the type property, which I define with its MIME type. In this case, it's the X Shockwave Flash MIME type. The next line is the data property, and here this points to the resource on the server. In this case, it's welcome.swf. So I know since the SWF file extension is a Swift file or Flash file. The next line is the width or the height properties, and these are some of those legacy HTML code that I was talking about. Here I'm defining the dimensions of this rectangular container that the browser has handed off to this object. through those two tags. The next section really is kind of unimportant at this point, to a certain degree anyway. Those parameter tags are a way to pass values to that application or that plugin. And then right below that you can see a little bit of HTML in between a div tag, and this is just a way for me to provide a link to the user to say, hey, if the browser didn't find this MIME type, this is where you need to go in order to install that plugin. So if you go, here's a screenshot of the plugins I have available in my Firefox browser. You can get to these through options add-ons. As you can see here, first one, Adobe Acrobat for the PDF viewer, quite a few other ones, Java, Google, Microsoft Office. For the next one, I'll take just a real quick look at extensions, and here you can see the as the author mentioned, the ones that typically use JavaScript to modify content already returned to the browser. So for example, here I have AdBlock, Firebug, NoScript, request policy. Looking at NoScript in particular, this is going to stop JavaScript from being executed while the DOM is being processed. So it's modifying content that's already being returned to the parent browser and not being handed off to any sort of plugin. So before we continue, a little bit more about MIME, the MIME types. Here you can see I did a screen capture of the content type returned to my browser when I requested that Swift file. You can see it's the X Shockwave Flash Player. Now in this case, it happens to match up with the type that was defined in that source code or in that HTML, so there's no problem. However, there are certain situations where the content type header is ignored and the type property of the embedded HTML is used. What this is saying is that when I request a resource off the server, it's typically going to, in its response, in those response headers, it's going to tell me what type of content or resource I am getting in return. However, that embedded HTML, that type property, can be defined, can be completely something different. I could define it as an image JPEG or a PNG or something. Where this causes an issue is that the hosting sites cannot restrict what plugins their content should go through. And one of the most famous examples of this is the GIFR example, in which a Java applet was smuggled inside a GIF image. And then finally, one last word of warning. JavaScript can be embedded in PDF documents, and VB macros are possible in Microsoft Office files. What this means is that when a script-bearing document, so a document that's able to execute scripts on the client machine, is displayed in an HTML page, a bridge is typically built between those two objects, so between the PDF and that browser. This is going to allow some degree of interaction with the embedding site. Here's an example what I think will really help solidify the danger of this. This particular example has been fixed, but it was discovered, I believe, in 2008. So it's really not that, relatively speaking, not that old of a vulnerability. What happens is if a user would go to example.com/random.pdf #foo equals JavaScript alert, when that browser would open, it would request that resource, it would render the PDF, and then that alert pop-up would appear. So that bridge would allow that JavaScript to be executed inside that browser. You can see this opens up a lot of doors for cross-site scripting and other DOM manipulation type attacks. So the bottom line here is just to exercise extreme caution when hosting or embedding any user-supplied documents. So now that we have just a real high-level general idea of what those plugins are and how they work and how they interact with the browser and the different resources that they can process from off of different servers, I'm just going to walk real quick through the different frameworks that are available. The first one, and arguably, well, it's not even arguably, the most popular is Adobe Flash. This is, Flash is built on ActionScript, which is based off of JavaScript. So a lot of how what's available in JavaScript as far as how it interacts with the system through the client and the browser is available in ActionScript. It's assessed that it is installed on 95 to 99% of all desktop systems. And I'd just like to point out that it's not to be mistaken for the Adobe Shockwave Player. However, the Shockwave Player is typically downloaded by mistake. Those are two separate, different MIME types that will map to two different separate type of plugins. So, as I mentioned earlier, typically ActionScript has the same capabilities of JavaScript, except there are a couple of major differences that are worth pointing out and taking a look at. The first one is that it can enumerate system fonts and other system information, which helps that action script basically fingerprint that system. Another one is that it is allowed full screen rendering, which opens the door for UI spoofing attacks. And then finally, ActionScript has the ability to request access to input devices, so such as your webcam, the microphone, the video camera itself. The only saving grace on this is that typically that requires the user to acknowledge that application is requesting those resources and permit it. It doesn't just happen behind the scenes. The next biggest framework out there is the Microsoft Silverlight framework. This is going to be built on the Windows Communication Foundation, which in a bigger picture is part of the .NET framework. What this means is that it's going to be written in a .NET language such as VB or C#. Now, Silverlight is designed, it was developed to compete with Flash. It has many of the features available as Flash, and it even has the same basic security model. So looking at those two, if you have to evaluate the security model, you can really hit two birds with one stone. Moving into the next one, we've got Sun Java. The Java framework predates Flash. It used to use what is now considered an obsolete tag, that applet tag, and it's nearly extinct. One of the kind of funny things about that is, though, that does maintain a relatively high install base. I think the author mentions about an 80% on desktop PCs, because it is still bundled with the Java runtime environment. So just something to be aware of when you're installing those in your browsers. The next one is the XML Browser Applications, or XBAP. This was another framework developed by Microsoft during the beginning of what the author considers the plugin wars. But it's losing support. It's disabled by default in IE9, and Microsoft is really focusing all their resources on Silverlight. The last one we're going to look at, just again real quick, is ActiveX. This is another framework that's being disabled by default in IE9. It's outside of Internet Explorer, it's widely unsupported, and during the time that it was still used predominantly by Internet Explorer, several hundred vulnerabilities were discovered in those web accessible ActiveX controls. So it was a very powerful framework that was developed not for the web. Finally, I'd like to summarize this chapter by taking a look at the security engineering cheat sheet that the author offers on page 138, just in case you're following along. He looks at two different scenarios we're dealing with files and the plugins that those files that those plugins process. So the first group is looking at serving plugin handle files. From here, he identifies 4 different scenarios in which you need to be aware of and be able to essentially answer, more or less questions to say, yes, I am safe in this environment, no, I'm not. The first one is from trusted sources. This is, the author says, typically pretty safe. The next is user-controlled simple multimedia. Again, a relatively pretty safe thing to do. The next one is user-controlled document formats. This is an increased risk just due to the way that those documents, how those different plugins are going to handle that document, say something like that MS Office document that will allow VB macros. Finally, there's the user-controlled active applications, and there's a little bit of typo there, so I apologize for that. And he says that these are just flat out unsafe to host. For the next group, it's embedding plugin handled files. For the first scenario we need to look at is the simple multimedia. Again, much like we saw from the previous group, this is generally safe. Document formats for the next one, usually safe, but there is an increased risk. Again, same things apply as we just previously discussed. Hosting Flash or embedding Flash or Silverlight, this is safe if set up correctly, and that has to deal with some of the property tags that are set up in that code, something that we don't discuss in this chapter. And then finally, Java, just due to the way that Java is run on that system, it's just not safe to load those from untrusted sites. So in conclusion, I hope that you got something out of this, the talking about browser plugins, how they work, how the MIME types work, how the browser requests those, and then how that plugin there then interacts with the system. If you have any questions, please feel free to post those on the discussion boards, and hope you guys have a good rest of the semester.